This is our lockout tagout center. All right. It has all the locks. They're all numbered per box that you're working on. So pay attention. Look at the box number that you want. Get the number off of that. Come back. Get the key that corresponds with that box. Pick it up. In this case, we're using number 2 box. Take it. Move on. Remember, this is your responsibility. Do not take it home with you. Stop at this. This should be the very last spot that you should go to at the end of the day or at the end of your time period that you're working with. All right, so now we're over in what I call the motor world, and this is where everybody trains to use these meters. Now, as the program expands and moves around, this may not be there anymore. It may only be one station here. You may have to go somewhere else, so just ask the staff personnel how to go and where to go to do this. So now the disconnect box that we're working with, we're going to understand and thoroughly pay attention to this. All our disconnect boxes have 2 locks on it. One lock, myself or the staff control. The other lock, you, the student, is going to control because it's the lockout tagout. Let's look at this. The first lock is just a regular master padlock. It prevents anybody from getting in the box. The lockout tagout lock is prevent anybody from accidentally turning this on. Pay attention to that because you're responsible. All right. Now, our keys are numbered 1 through whatever we have out here, 29 or something, and they're over right by the homework box on our side of the classroom, and they're numbered. Just match the number up with the box, and they should work, hopefully. All right, so the first thing is unlock the box and set it down. Remember, this is your lock. It's not my lock. It's not anybody else's but yours. You're totally responsible for it. The second one is take the second lock off, and you can open up the box. To do that, it has a little catch. Just open it up. Now, from this point on, you need to have your glasses and gloves on because you do not want to be touching stuff inside the box without them. Take all your jewelry off because, as we know, electricity will jump. Now, understand this clearly. These wires right here are your line wires. Line is anything that is coming into the box from an outside source. The load is typically on the downside, and they're marked load 1, 2, 3. That is always going to something like the motor or the ice machine or some load carrying device will be taking care of that. So pay close attention. Do not stick your fingers in there without knowing what you're about to touch. Over on this side, you'll see where the green wires or the grounding wires are. All right, those lugs are your ground. That's the ground for that box. So when your instructions tell you, well, go from line 1, which is here, to ground, you'll understand what they're trying to ask you for. Now, remember what I said. I'm going to use the Flute or the field piece because it's all in one and I can do everything from that meter. But again, you know, the key to success is to know all the equipment that you can work with, and you'll be a much better tech. All right, again, red to red, black to black. All right, now I'm working with AC, so therefore I'm turning it on to AC. I check my screen, it says AC, it's in the auto mode. All right, now understand something. People come up to me and say, oh man, this meter's already reading and isn't hooked up to anything. Well, that's 0.004, all right, volts. That's 4 thousandths of a volt. Don't worry about it. Just go to the first spot, all right, after the decimal point, the tenths. you got 0 volts. Now, pick up your leads, inspect them. If for some reason somebody did some damage to these, stuck them where they weren't supposed to stick them and shorted them out or rounded them, whatever, let me know. All right. We've had accidents on these before because students are pulling the wrong wires. They get in a rush. Electricity, you have to respect. You must respect it, period. You have to understand it thoroughly. If you don't, you will end up getting hurt or killing somebody else. So, gloves are on, jewelry's off. The first thing I want to do is I want to go from line 1 to line 2. Okay, so I see right here is line 1 and this is line 2. Well, trying to get a stick through this, ridiculous. Just stick it over and you'll see what I'm talking about here. All right, you see the big screw there, just stick it in there. All right, the same thing on the other side. Now, hold that and look at your meter. All right, the meter in this case is reading 209 volts. All right, don't worry about that decimal point. And you also notice that the high voltage is being triggered. Anything over 120 is going to do that. All right. What does that tell me as a tech? What it tells me is that there's voltage flowing through both of these lines. Now, we just read 208, 209, give or take. Don't get locked into all this precise voltage. All right? But how do I know what my voltage is on only one line? Well, I stick my probe up into L1 and I always go to ground. All right? I look at my meter and I can see that I'm only getting 120 volts. Now, I'm not here to teach you how to calculations at this point in the game. But if you, common sense tells you, well, if it's 120 on one leg, then it's got to be 240 on the next leg and 360 on the third leg. Wrong. That's not how they calculate this stuff. What they do is there's a formula, and we're not going to discuss that to you, but understand that 120 is going to be basically the reading that you're going to get from the meter when you hit leg 1. As if you go from leg to leg, you're going to get the 208, 209 version. All right? And there's a reason for that, and as you go down the courses, you'll understand how they come to that conclusion. But what you always want to do as a tech is go through each line to ground and be sure that you got the correct voltage coming through there. Then what you want to do is you want to go from line to load. What you want to do is put one lead on load 1 down here and one lead on line 1 up top. Oop. Okay. And you're getting about 109 volts. Now the reason you're getting that is because there's some resistance in the meter that's breaking it down, so you're not getting at 120. Don't get overly concerned about that. All right, but you just know what it's doing is, why am I getting, the question you should be asking yourself is, why am I even getting voltage through my meter? Well, the reason is simple. I have voltage coming through here. This is my potential right here. What's potential? Means that it's there, but it can't go anywhere yet. It's just in a holding pattern like an aircraft. But when I go and touch this lead to that point, now that potential has a way of getting out. And what it's doing is it's going through my meter and it's coming out here at the other end of this one. But when I go to touch the other end, it completes the circuit flow and it allows it to run through. And that's what I'm reading. That becomes very important when you start checking fuses and stuff. All right, so now we've discussed all the top portion, the grounding portion, and the load portion. Now what you're going to end up doing is following your instructions. because it's going to walk you through this. All right. Now what we're going to do is we're going to turn the motor on. Now all you have to be concerned about is redoing the same measurements, but being cautious of what's around you. All right. This motor will kick in. All right. It's automatically tied in. That's our load. All right. Down here. So when you go to start it up, be sure everything's clear. We've lost a couple leads because people are not paying attention. They got them wrapped around the shaft, and then, of course, they're wondering why the leads have been ripped out of their hand and yanked over across town. So, when you go to start this, yes, you should close the box. All right? But you can't take any measurements there. In our profession, we have to work with live voltage. So what you have to do is all disconnect boxes have an idiot switch. All right? You have to push this up and at the same time raise the handle. All right? Now, when it's in the up position, it's going to be on. Motor connected or otherwise, that voltage is going to travel through. The question is where is the voltage? The voltage is being consumed by the motor. If you didn't have the motor connected up, the potential would be down at the load side of the lugs. Now what we want to do is we want to go back and take some same measurements here. Again, from line to line, line 1 to line 2, you get 208. From line 1 to ground, you get 119. All right? And from line to load 1, excuse me, line to load 1, you should get 0 reading. All right? If you're not getting 0 reading, there's a problem. If you go from load 1 to ground, you should come back to 118 volts. All right? Now let me shut that off so you can hear me a little bit better. And when you're not using your meter, just turn it off. All right? Yeah, it is idiot proof, but it has a little time delay. And this is what causes a lot of problems. Students just take for granted that the meter is going to turn itself off, and it does, but it wears out the battery much faster. Now, we took a reading of 119 at the top to ground, and we took 119 or 18 to ground from the load side. Why are we doing that? Because we want to be sure that this fuse in here, being this is a 3-phase motor, meaning that all 3 of these phases in this wire are working. All right? It's producing energy coming down through the fuses and into the system. If I went and I came up here and the motor wasn't, let's say it was making some noise or wasn't working for one reason or another, and I went from line 1 to load 1 and the motor's on, a 3-phase motor may very well run for a while. All right? But as you'll understand later, what happens is it heats up the motor. So from line 1 to load 1, I get a 0 reading on my meter. What is that telling me? Remember at the beginning of this thing I told you, electricity is always going to take the least path of resistance. That's the same concept. Remember when you got that odd reading of 109 and the motor wasn't running? That was the voltage that you were collecting because it was using the meter. Well, now it's running and there's no voltage in my meter. Why? Think about this. Least path resistance. Just like water. Water will take the least path of resistance. Same thing here. When the voltage comes into the box, it's going to take the least path to its product, the load. In this case, we have a fuse and we have a meter. If that fuse was bad, I would be reading 120 volts. If the fuse is good, the electricity path is going through that fuse because there's less resistance than there is in this meter, i.e. least path of resistance. If there's anything you walk away with is understand how to read your meter, how to use it against the equipment, and electricity always takes the least path of resistance. I will tell you from personal experience and over years of teaching this stuff, if you don't understand those 3 rules, do not walk away from this exercise. I don't care if you do it in 5 minutes or 5 days, because I guarantee you down the road, you're going to be cursing up a storm while you can't figure something out. You have to memorize this. All right. Now, that's enough on the voltage. What we're going to move on to now is the amps and how to use the clamp-on amp meter. Now, my box for demonstration purposes is open. All right. I want you to fully understand this system. Now, remember, rule 1. Turn it to the right. You don't know how many times, and you probably do it, people get caught trying to figure out how many ohms there are on an amperage reading. And they're going, oh, this meter doesn't work. No, it isn't the meter, boys. All right? So, set your meter first so that you understand in your mind what are you doing. The second thing that you have to do is pick out the location in which you're going to read the amperage being used by this motor. Now, do not, and I emphasize do not, do this. Put it around the one wire, set it there, and then go turn the motor on. There is a thing called lock rotor amperage and run load amps. All right? Don't get them confused. All right? If you don't understand that, go back to your reading. You must have the motor running first before you start taking measurements. All right? Again, the idiot switch is up here. You turn it on. Check your meter. Come down, select the wire that you want to do, and wrap it around. Now, there is a hold button here, because there'll be some cases where you won't be able to see what you're actually taking a reading. It's more dangerous to do that. But you can pull it apart and sit there and look at it and see that you got 7.32 amps. All right? Unhold it, go back and take another reading. Hold it again. Unclamp it, bring it up where you can read it. 7.84. Release it. And then the last one, do the identical same thing. You notice that we get 7, but all the fractional is different. What that's telling me as a tech is that all the wiring in here has a different amount of resistance, and some are taking more than others. Is it unbalanced? No. It doesn't meet the criteria for an imbalanced system. What it's telling me is that windings wear out at different modes. Also, if you look at the plate here, the plate tells you something like 14 amps. Well, we're only getting 7. Why is that? Well, the reason that you're getting that is simple. There's no load on this puppy. All right? Without a load, it really does more damage to the motor without a load. Or if the load is too heavy, it will damage the motor. Without taking an amp reading and trying to get it as close to 14 or whatever the amperage is set for, this is going to cause problems on your unit. Therefore, pay close attention how to take the amps, what your amp reading is. Also, in some of the exercises, excuse me, forgot to turn it off again. See how easy that is? On some of these exercises that you're going to do, because this video that we're making works with several different programs. This doesn't mean that you're going to do each and every one of them, but eventually you will get your hands into this, so pay attention. You notice the rotation of a motor? In this way, it's going clockwise. This is a 3-phase motor. If I change any two of these wires or any of the two of the load wires inside, that motor will automatically begin to turn backwards, counterclockwise. That's only on the three-phase motor, unless you buy motors, fractional horsepower motors, that have a pin delivery system where you can switch them back and forth. They're nice, but they're much more expensive. So understand what direction you're going in your fans so you don't have to spend that amount of money and charge it back to the customer. All right? So we've discussed using the amp probe. We discussed using the meter for reading voltages. All right? So you should have a pretty good solid basis for that. Again, before you leave, and you never leave this station without that box being closed, and at least your lockout tagout on it. All right? Do not get in a rush. I'm telling you, that's how people get hurt. All right? Don't stick this in your pocket, because I will be very upset that I can't get into this box, because this is the only key to that lock. And then you ruin it for everybody else. So slow down and pay attention to what you have to do. If you got to go to the bathroom or something, lock it. You're responsible. If I get shocked, you're going to jail. Period. If you make it that far. Okay? So now, it doesn't matter what meter you use, it all works the same. All right? It all functions in the same process, and you get the same results. Now, what we're going to do is show you how to read resistance with this. We're going to move on to resistance and capacitance.